Exercise related to electromagnetic induction. We'll do question 14 now, question 15 now. In question 15, regenerative braking is used in electric cars. So what happened, it used the same concept of the back EMF. So when the driver applies the brake, the motor act as an electrical generator. And making use of the rotation of the wheel as this slow down, this enable the battery to be charged once the car is braking. So when the car is braking, the rotation of the wheel is actually used to rotate this coil, and which induces EMF, and that EMF produces a current, and we store this electrical energy into a chemical energy which changes by using the battery. The diagram shows a coil in a magnetic field which when rotate can be used as an electric generator. So same concept of electric generator. The coil rotates, explain how this produces a current, 3 marks. So you have to learn the standard structured answer for this. How the induced EMF is produced, like how there's an induced EMF. So first thing you will mention that there's a change in magnetic flux linkage, or the coil will cut the magnetic field lines. That is 1 mark. And as it cuts the magnetic field line, or there's a change in magnetic flux linkage, it will induces EMF, or it produces a current, and it produces a current because there's a closed circuit. So how to score 3 marks? 1 mark for mentioning as the coil is rotating, there's a change in magnetic flux linkage, or it cuts the magnetic field. Second mark is it induces EMF, which generate a current because we have a closed circuit. If there was no closed circuit, there will be no current. But the circuit is closed, that's why the current is produced. Why the current produced in a coil cannot be used directly to charge a battery? So the current which is produced here, it won't be a constant current. It will produce, because as the coil is rotating for a half cycle, the direction of a current will be different. Let's say if this was a side A, B, C, and D. So when the coil is rotating either clockwise or anti-clockwise, so when it flip, so this position will be B, this position will be A, this will be D, and this will be C. So as the coil flip, the direction of induced current will be different as well. So actually it is producing current in 2 directions. So, or we can say it's producing an AC current. AC current cannot be used to charge the batteries, or even we cannot use a capacitor. Capacitor cannot work with AC or the battery. So we need a direct current here. That's why we cannot directly input this current. First, we have to connect a diode there, and then the battery. So you can mention 2 points. One is the current produced will be alternating. The second point you can mention, it will produce a variable current as well, alternating variable current. So we have to use a diode before sending this current to a battery. When regenerative braking is being used, explain how the magnitude of a generated EMF changes as a driver brakes steadily. When the driver is applying a brake, what will happen? So the speed of rotation of the wheel will decrease. So as the speed of rotation of the wheel will decrease, because like when the driver is applying a brake, in the beginning the coil is connected to the wheels. So in the beginning, as the car is moving faster, the rotation will be much greater. As the wheel is rotating faster, the coil will rotate at a higher speed. But as it is breaking down, it is decelerating. So the speed at which the coil will rotate, the speed of a rotation of a coil will also change. In the beginning, it is faster and then it is slower. So as a result, what will happen? The induced EMF will also decrease. So, but how to score the marks? How we'll get the marks for this question, as it is of 3 marks? First thing we'll mention, as the speed of rotation of the wheel is decreasing, so the magnetic flux linkage will also decrease. which induce a smaller current, as the EMF is directly proportional to magnetic flux rate of change of magnetic flux linkage, so the induced EMF will also decreases steadily. Is it clear, this one? That why it will produce a smaller current?